concept of subset, superset and power set. First we discuss about subsets. Consider the two sets, set A and set B. Set A contains 5, 4, 8 as element and set B contains 1, 5, 6, 4, 8 as element. Do you see any relationship between set A and set B? Observe that every element of set A is an element of set B. In this case, we call A to be a subset of B and we write it like this. By definition, if A and B are any two sets, then set A is said to be a subset of set B if every element of set A is also an element of set B. We write it as you know, A subset B. Read as A is a subset of B or A is contained in B. Conclude, A subset B if and only if X belongs set A implies X is also belong to set B. Now, if A is subset of B, we say that B contains A. In this case, we say that B is a superset of A. We write it as B is superset of A. Consider two sets A and B. Set A contains F, O, L, W and set B contains L, O, W, E, R. Observe that there is an element F in set A which is not a member of set B. So, set A is not a subset of set B. We write it as A is not a subset of set B or A is not a subset of set B. Read as A is not contained B. If there exists at least one element in set A which is not an element of set B, then we say that set A is not a subset of set B. Today we are discussing about proper subset. Now we look for another concept of proper subset. Let's take two sets, set A and set B. Set A contains element 4, 8, 12. Set B contains element 2, 4, 6, 8, 10, 12 and 14. Observe that set A is a subset of set B. As we see that some element of set B which are not in set A means 2, 6, 10, 14 belong to set B, but 2, 6, 10 and 14 does not belong to set A. So in this case we say that A is a proper subset of set B. Let A be any set and B be a non-empty set, then set A is called proper subset of set B if and only if every member of set A is belong, or basically every set is also a member of set B and there exists at least one element in set B which is not in set A. We write it as A is proper subset of set B. In other words, we say that set A is a proper subset of set B if A is a subset of B but A is not equal to set B. Now, conversely, if two sets, set A and set B are such that A is proper subset of set B and set A is not equal to set B, then set A is called a proper subset of set B and set B is called superset of set A. Some important points. Every set is a subset of itself. A subset which is not a proper set is called an improper subset. Every set has only one improper subset, and that is itself. An empty set is a subset of every set. An empty set is a proper subset of every set except itself. Number 6, every set is a subset of a universal set. Now we can also find number of subsets and the number of proper subset of set A or any set. To know what these numbers are, let us suppose that cardinal number of a set A is m. Now n A is equal to m, then the number of subset of set A is equal to n to the power m, and the number of proper subset of set A is equal to m to the power m minus 1. For example, if set A contains element 1, 3, 5, then its cardinal number Na is equal to 3. So number of subset of set A is equal to 2 to the power m is equal to 2 cube, which is equal to 8. These are the null set 1, 3, 5, the set of 1 and 3, set of 1 and 5, set of 3 and 5, and the set 1, 3, 5. These are 8 subsets of set A. Number of proper subset of set A is equal to 2 to the power m minus 1, which is equal 8 minus 1, which is equal to 7. Now let us discuss about power set. The collection of all subset of set A is called the power set of set A. It is denoted by PA. In PA, every element is a set. If the number of elements in a set A is m, then the number of elements in the power set of a set A is 2 to the power m, or NPA is equal to 2 to the power m, where NA is a cardinal number which is equal to m. Now another type of set called universal set. A set that contains all the elements under consideration in a given problem is called universal set, and it is denoted by capital U, capital S, or this symbol. Let us consider three sets X, Y, and set U. As we see, set X has contained all the consonant of English alphabet. Set Y contains all the letter of the word education, or set U contains all the letter in English alphabet. Do you see any relationship between these three sets? The set U contains all the elements which are in set X or set Y. This is works. The set U is a universal set of set X and set Y.